When three galaxies collide, what happens to the huge black holes at the centers of each? A new study using NASA's Chandra X-ray Observatory and several other telescopes reveals new information about how many black holes are furiously growing after these galactic smash-ups. Astronomers want to learn more about galactic collisions because the subsequent mergers are a key way that galaxies and the giant black holes in their cores grow over cosmic time. There have been many studies of what happens to supermassive black holes when two galaxies merge, but this is one of the first to systematically look at what happens to black holes when three galaxies come together. Researchers identified triple galaxy merger systems by cross-matching the archives containing data that is now publicly available of NASA's WISE mission and the Sloan Digital Sky Survey, or SDSS, to the Chandra archive. By doing this, they found 7 triple galaxy mergers located between 370 million and 1 billion light-years from Earth. Using specialized software, the team went through Chandra data targeting these systems to detect X-ray sources, marking the location of growing supermassive black holes. As material falls toward a black hole, it gets heated to millions of degrees and produces X-rays. Chandra, with its sharp X-ray vision, is ideal for detecting growing supermassive black holes in mergers. The associated X-ray sources are challenging to detect because they are usually close together in images and are often faint. The new software was developed specifically to find such sources. Data from other telescopes was then used to rule out other possible origins of the X-ray emission unrelated to supermassive black holes. The results show that out of 7 triple galaxy mergers, there is 1 with a single growing supermassive black hole, 4 with double growing supermassive black holes, and 1 that is a triple. These black holes are separated by a range between 10,000 and 30,000 light-years. In the final triple merger, there was no evidence of X-ray emission. This means that none of the supermassive black holes left was rapidly pulling in matter. Astronomers will continue to use Chandra to learn more about what role mergers play and how galaxies and the giant black holes in their centers grow over cosmic time.